Hey kids, this is Mr. Tom Tom. Today we are talking about space. So let's get ready for Mr. Tom Tom and STEM Kids in Space. How can we float? Well, to float, we've got to get into space, away from the force of gravity of Earth or some other object, wherever we may be. Well, how do we do that? Well, to do that, we have to apply some laws that Newton discovered many years ago. He had 3 laws of motion, and today we're going to talk about the third law of motion, which is for every action there is an equal and opposite reaction. Now, I'm just sitting here, there's nothing going on. I've got to get up into space. It's up there. Well, up there is just the ceiling, so I got to go higher than that. If I go outside and look up, well, I may just see the clouds. I gotta go a lot higher than that. And if I look up at the blue sky, well, I don't see anything, because all I'm seeing is atmosphere. I've got to get up above the atmosphere into space. Well, that's quite a ways up. But to stay in orbit, to fly around the Earth, we have to be about 100 miles up. 100 miles. How far is 100 miles? Well, let's see, if you're on the West Coast and you're at Disneyland and you want to drive down to San Diego Del Coronado Hotel, that's about 100 miles. Or let's say you're in New York City and you drive to Philadelphia, that's about 100 miles. Or, make it a little more practical to what we're talking about, space, STEM Kids in Space! Let's say we are at Kennedy Space Center in Florida. If we were to drive west to the city of Lakeland, Florida, which is just east of Tampa, that is about 100 miles. So we got to go up 100 miles, and then we've got to be going 17,000 miles per hour to stay in orbit around the Earth. 17,000 miles per hour. Now, I was just talking about driving. Depending on what the posted speed is and how fast you're going, that might be 55 miles an hour, it might be 70 miles an hour. Some people may be going 80 miles an hour, and when you're going 80, 90 miles an hour, you might see some blue lights in your rear view mirror. So we're going to go the speed limit because that's safe, and space is about safety. So we got to go up 100 miles, and then we gotta be driving 17,000 miles. Orbiting, flying at a speed of 17,000 miles per hour. So to do that, we've got to get moving. And the way we do that is we apply Newton's third law of motion, which is for every action, there is an equal and opposite reaction. We've got to somehow go up by pushing down. And we've got to go this way by pushing that way. The way we do that, usually with rockets, is with rocket engines. With a whole lot of force pushing one way, which pushes the rocket in the other direction. That is Newton's third law of motion. For every action, there's an equal and opposite reaction. Well, we can demonstrate this. If you're standing up, you can jump up in the air. You're pushing down, and then your body goes in the other direction. If you jump, no matter how hard you jump, you're not going to get up 100 miles. You might get up a couple inches. You might be able to get up maybe even a foot. And if you were to jump 12 inches, and then from that point, jump another 12 inches, and then from that point, jump another 12 inches, and keep going till you got all the way up to 100 miles, you would be in space. That's why we use rocket engines. But we can demonstrate some simpler engines. For every action, there is an equal and opposite reaction. Let's just breathe. Don't breathe hard, just there's a force. Air is coming out, and it's pushing on your body the other way. It's so little, you don't feel yourself moving back when you breathe. But we can measure it. Most of us have 2 hands. Some of us only have 1 hand, and that's okay. But this is a force measurer, a relative force measure. If you put your hand in front of your mouth and just breathe normally, you can feel a small force pushing against your hand. Now, what if we increase the pressure in our mouth? Now my hand didn't actually move, I moved it. But there's a greater force. Try it. Now let's make a whole bunch of force. Blow really hard. Do you feel the difference? Can you measure the difference relative? Just breathing, pressure, a little bit more force. Blowing really hard, even more force. Now, as hard as we try with all of our might, no matter how hard we blow, we cannot blow ourselves up into the air, let alone 100 miles into space. For every action, there is an equal and opposite reaction. So, if we can get enough force, enough pressure, big enough rocket engines, we can get up into space. Consider our little pressure that we just made. That's actually what we use on rockets. Think about it. If you see rockets returning to Earth, they have little thrusters on the side. You can see them in videos. That's just compressed air that is helping steer the rocket. For every action, there is an equal and opposite reaction. There is so little air up there, so little resistance, that just that air pressure is enough to push the rocket back and forth, to line it up to land where they want it to. Or, if the rocket is in space, they can rotate the rocket with that air pressure. Now, sometimes you want to push the rocket that way. Sometimes you want to push the rocket that way. So you can have a little valve to go each way. Try this. Blow on one side and then blow on the other. Well, what did we talk about today? Who discovered the 3 laws of motion? Do you remember? Newton. Do you remember their first name? Isaac Newton. Which of those 3 laws did we talk about? The third one. And what does that law of motion say? For every action, there is an equal and opposite reaction. How high do we need to go up to be in orbit around the Earth? For low Earth orbit? 100 miles. How fast do we have to be going to stay in orbit at 100 miles? 17,000 miles per hour. That's pretty fast. Right. Wow. We've talked a lot about space today. We have other videos. Check those out as well. Be sure to subscribe. Check them all out. Try the activities yourself. And let's remember, we all can be part of Mr. Tom Tom and STEM Kids in Space.